There's a place under the Red Sea that has long amazed scientists. It's not an island, nor is it a cave. Instead, it's like a lake that's actually under the sea itself. At first glance, it seems impossible for this to happen. Because if everything around is water, how can there be another lake under the water? But in reality, it truly exists. But before we start the discussion, I'd like to ask you for a like and please subscribe to our channel as well. This is a huge help for us content creators. So let's get started. At depths of more than 1,500 meters, reaching down to 2,000 meters, there are parts of the Red Sea that contain what are called brine pools. The water here is extremely salty, several times saltier than normal seawater. Because of its extreme salinity, it doesn't easily mix with the surrounding water. That's why it remains like a separate lake beneath the ocean. When viewed using the lights of a deep-sea submersible, the clear boundary between the two types of water is very visible. It's like a mirror lying on the ocean floor. On its edges, you can even see what look like small waves. This isn't an illusion. This really happens because of the big difference in the salinity and density of the two types of water. But what they discover next is even more unusual. There's almost no oxygen inside these brine pools. Aside from that, the salinity is extremely high, and there are also a lot of chemicals. That's why? For most fish and other sea creatures, entering this place would surely mean death. That's why there are often fish or other animals that get lost at the edge of the brine pool and never make it out again. Because of this, some scientists call these places the death traps of the deep ocean. And while almost no large animals live inside these, there are other forms of life that can survive here. This includes some of the most extreme creatures, tiny microorganisms that don't rely on sunlight to survive. Instead, they use the chemicals around them as their source of energy. This means that even if the place is permanently dark and there's almost no oxygen, they still find a way to survive. Because of this, scientists are now studying brine pools more closely. It's possible that this is what the place where life first began on Earth looked like, billions of years ago. And that's not all. If there is life that can survive in such extreme conditions here on our planet, it's also possible that there is a similar kind of life beneath the icy oceans of other worlds. Just like some moons of Jupiter and Saturn that are believed to have hidden oceans beneath thick ice. In other words, the mysterious lake beneath the Red Sea is not just a strange natural formation. It is also a natural laboratory that could provide answers to one of humanity's biggest questions. Despite this, why does it seem like there's a separate lake beneath the ocean? The answer is that the water there is much saltier. When more salt is dissolved in water, it becomes heavier. That's why the extremely salty water in the brine pool sinks and accumulates at the lowest part of the seafloor. It's like this. When you're floating in the sea, it's easier for you to rise than in a swimming pool. That's because seawater has salt. The water is heavier, so it can push your body up more. The same thing happens in the brine pool. The water inside it is much saltier and much heavier compared to the normal seawater above. That's why it doesn't just rise, and it also doesn't spread quickly. It just stays at the bottom, like a thick blanket of water lying on the ocean floor. Because of this, there is a clear separation between the normal seawater and the extremely salty water. In the submersible's camera, it looks like the surface of a lake. It has edges, boundaries, and sometimes there are even ripples like small waves. But this isn't magic, it's just science. The normal water on top is lighter, the brine at the bottom is heavier. So even though they're both water, they don't mix right away. But there's another reason why the brine pool stays intact. It's not just salty. In some parts of the Red Sea, the deep brine water can also be hotter than the water above it. When heat and salt move together, a unique process happens between the two layers of water. Heat spreads faster than salt. This means that heat transfers to the surface water first, while the salt spreads more slowly. Because of this, it's like there's an invisible wall between the normal water and the brine pool. It's not a wall made of stone. It's not a mirror. But the difference in weight, salinity, and temperature is enough to keep their boundary clear. So when the submersible's light passes through, the boundary is very visible. It's like you're looking at a lake. But that lake is under the sea. In some places in the world, brine pools are small, but there are others that can reach enormous sizes. There are brine pools that look like lakes, some that look like rivers, and some that move like waterfalls under the ocean. According to Noé, brine is heavier than ordinary seawater because it contains more salt. That's why it can flow along the seafloor and accumulate in deep pits under the sea. And in the Red Sea, according to studies on deep-sea brine pools, there are areas that are extremely salty, almost without oxygen, and have unusual chemistry. This means it's not ordinary water. It's an extreme environment that most marine life cannot inhabit. But there's still a question here. If a little bit of salt still escapes from the brine pool, why doesn't it run out? Why doesn't it slowly mix with the rest of the ocean until it disappears? This is where the bigger secret of underwater lakes comes in. The brine pool isn't just leftover salty water. In many places, it continues to be replenished from beneath the seafloor. Under the sea, there are ancient deposits of salt buried in the rocks and soil. When water passes through them, the salt dissolves. As a result, the water becomes extremely salty. Afterwards, due to pressure and cracks under the seafloor, the salty water can rise and come out onto the seafloor. When it reaches a pit or a low area, it accumulates there. So while some brine escapes above, new salty water can enter from below. It's like a bucket with a small leak, but there's also a faucet slowly filling it up. That's why the brine pool doesn't disappear right away. And the longer it stays, the more unique its surroundings become. At the edge of the brine pool, there are also organisms that can survive in extreme conditions. They're not like ordinary fish that need normal oxygen levels and sunlight. Some of them rely on chemicals coming from beneath the sea. But there's another question. Where does that new salty water come from? The answer is hidden in the history of our planet. Millions of years have passed. According to studies by geologists, true deep-sea brine pools don't just form anywhere. The most well-known places with this type of lake are the Red Sea, the Gulf of Mexico, and some parts of the Mediterranean Sea. There is one more important thing that these three places have in common. In ancient times, these places were not always connected to the major oceans. At times, they were nearly cut off from other seas due to continental movement and land changes. Because the entry of new seawater was limited, large parts of these basins gradually dried up due to intense evaporation. As the water evaporated, it left behind a huge amount of salt at the bottom, and over millions of years, thick layers of salt were buried by mud, sand, and other sediments. As more sediments accumulated on top, the salt became buried deeper beneath the earth, but the process doesn't end there. Over time, the sediments on top also become heavier and heavier. Because salt is softer than hard rocks, it starts to get squeezed and move underground. And scientists call this process salt tectonics. In other words, the thick deposit of salt is gradually being squeezed because of the weight of the rocks above it. Because of this, cracks and pathways form under the seafloor. When that happens, seawater can seep down into the old salt deposits. As the water passes through, it dissolves a lot of salt. The result is a highly concentrated brine or extremely salty water. Then, because of the heat coming from inside the earth and the pressure underground, the hot and dense brine slowly rises up out of the seafloor. When it reaches the bottom of the sea, it doesn't immediately mix with the surrounding seawater. Instead, it sinks to the lowest part of the seafloor, and there it forms a new brine pool. So while a small amount of salt is lost from the surface of the lake, new salty water continues to arrive from beneath the earth. This is why some brine pools can last for a very long time. But it's not just lakes that can be formed by extremely salty water. Sometimes it can also flow. In 2018, while researchers were conducting an exploration in the Gulf of Mexico using a remotely operated vehicle, they noticed something unusual at the edge of a brine pool. At first, they just saw an ordinary brine pool. The water was dark in color. Around it were many dead shells and other sea creatures that did not survive after entering the extremely salty water. But when they raised the camera, they found something even more surprising that survived. They saw a long trail of dark brine flowing down the slope of the seafloor, as if there was a river running beneath the ocean itself. As they followed its direction, they noticed that the extremely salty water kept flowing down into a larger brine pool, just like a real waterfall. The only difference is it's not fresh water that's flowing. It's a waterfall of extremely salty water beneath the sea. According to Noé and oceanographers, this kind of phenomenon is possible because brine is heavier than normal seawater. So instead of floating, it flows down the slopes of the seafloor, just like how a river flows on land. This means there are places under the ocean where there are lakes, rivers, and even waterfalls. And all of these are made of extremely salty water that almost doesn't mix with the surrounding sea. And what's even more amazing is that some of these systems may have started forming as far back as the time of the dinosaurs, more than 180 million years ago. Until now, they still continue to exist beneath the dark and quiet parts of our planet. But it's not just the lakes and waterfalls that are unique in this place. What's even more surprising are the creatures that live around it. If you think about it, it really seems impossible for anything to survive here. There's almost no oxygen in the water, and the salinity is extremely high. There are chemicals like methane and hydrogen sulfide that are poisonous to many sea creatures. It's permanently dark, and the pressure is immense because of the extreme depth of the ocean. At first glance, you might think this is probably one of the worst places for any kind of life, but that's not true. In fact, it has its own ecosystem. When scientists examined the edges of the brine pool, they found many dead fish, crabs, lobsters, and eels. Some of these have been dead for a long time, but they don't decompose right away because of the extreme salinity and unusual conditions of the water. It's like a natural preservation chamber under the sea, and the researchers also noticed a strange phenomenon. When a fish gets close to the edge of the brine pool, it often avoids it. It's as if they know the place is dangerous. But when one gets lost and actually enters the extremely salty water, it only takes a few seconds before it loses control of its body. According to studies, the sudden exposure to extremely high salinity can cause severe stress in fish. They have difficulty controlling their movements and quickly become weak. If they are unable to return to normal seawater right away, they usually die. Aside from that, there is almost no oxygen inside the brine pool. So even if they survive the extreme salinity, they will still have difficulty breathing. But while the inside of the lake itself is dangerous, the opposite happens at its edge. That's where a unique community of sea creatures begins to form. You can find vast colonies of tube worms there. There are also large mussels that can live for a very long time. Around them are shrimp, snails, small crabs, and other unusual animals that are rarely seen in shallow waters. Why do they crowd together in such a dangerous place? Because there's plenty of food for them. The chemicals that come out from beneath the seafloor serve as a source of energy for microorganisms. These microorganisms serve as the foundation of the entire ecosystem. They do not rely on sunlight. Instead, they use chemicals from beneath the earth to produce energy. This process is called chemosynthesis. Because of these microorganisms, there is food for tube worms and mussels. When they multiply, shrimp, crabs, and other small animals arrive. And when the small animals increase, even smaller ones follow. And large predators like fish, octopus, and eels. In other words, even though the place is very dangerous, it still serves as an oasis in the middle of the deep ocean. But there is one creature that surprised scientists even more. It's the hagfish. It is one of the oldest types of vertebrates still living today. It has existed long before the dinosaurs appeared. What's even more surprising is that it seems to be able to move in and out along the edge of the brine pool without being immediately affected like other fish, while other animals quickly weaken. When submerged in extremely salty water, the hagfish can enter to get food and come out again. Scientists still do not fully understand this, why it is tougher than most other sea animals. Research is still ongoing to find out what is special about its body, and this is where brine pools become even more important. They're not just strange lakes under the sea. They're natural laboratories where scientists study how organisms survive extreme heat, high salinity, lack of oxygen, and toxic chemicals. This knowledge is not only important for understanding life on Earth, it can also help in the search for life on other worlds, especially in places with oceans beneath thick ice like some of the moons of Jupiter and Saturn. And even more surprising, this entire ecosystem does not revolve around sunlight. There is another element that serves as the main source of energy for many organisms here. It is a gas that, in other situations, is considered dangerous and toxic. But here, in the depths of the sea, it is what helps keep the whole community of creatures alive. But there is an even bigger question. If there is no sunlight at the bottom of the sea, where does the food for all these animals come from? In almost every place on Earth, life begins with the sun. Plants use the energy from sunlight to make their own food. This process is called photosynthesis. Then the plants are eaten by other animals, and those animals are eaten by even bigger animals. This is how the food chain works in almost the entire planet. Even in the deep ocean, there is still life that depends on the sun. How? Because there are tiny pieces of dead plankton, algae, and other organic material that slowly sink from the surface of the sea. Scientists call this marine snow. It serves as food for many creatures in the deep. But something different happens around the brine pool. There's almost no marine snow there, certainly not enough to support so many organisms. This means that this ecosystem has a different source of energy. And this is where one of the most important discoveries in marine science began. When scientists studied the large mussels living on the edge of the brine pool, they noticed something unusual. Inside their gills were a lot of bacteria, but these weren't ordinary bacteria. They had a unique ability. Instead of using sunlight to make food, they use chemicals that come from beneath the earth. These include methane and in some places hydrogen sulfide. This process is called chemosynthesis. In other words, while plants use sunlight to make food, bacteria at the bottom of the sea use energy from chemicals. So even without sunlight, they can still produce food. The bacteria are the first to create energy. Afterwards, other organisms eat them or benefit from them. This is where the entire food chain of the brine pool begins. There is another fascinating relationship between the bacteria and the mussels. The bacteria provide the mussels with food and energy. In return, the mussels protect the bacteria inside their bodies. It's like they help each other so they can both survive. Because of this partnership, the mussels multiply around the brine pool. When the mussels increase in number, the shrimp, crabs, lobsters, and other animals that live between their shells also increase. And when there are many small animals, the bigger predators arrive. So even in the middle of a vast and almost lifeless part of the ocean, the area around the brine pool becomes like a small city for marine creatures. When scientists first saw this, they were amazed. Because this showed that not all life on Earth depends on the sun, there are ecosystems that can survive even without a single ray of light. This discovery became even more important when scientists began to study how the first life on our planet began. For a very long time, many scientists believed that life began in shallow, warm waters that were exposed to sunlight. In 1871, in a letter, Charles Darwin suggested that life might have started in a small, warm pond with various chemicals. Later on, the idea of the so-called primordial soup was developed. According to this theory, simple chemicals in shallow water gradually combined until the first life was formed, using energy from sunlight, heat, and possibly lightning. For many decades, this was one of the most widely accepted explanations about the origin of life. But when ecosystems were discovered around hydrothermal vents and brine pools, the perspective of many scientists began to change when they realized that sunlight might not be necessary for life to begin. It's also possible that life started in the depths of the ocean, where there is heat from within the earth and many chemicals that could serve as sources of energy. Until now, there is still no single theory that has been proven correct about the exact origin of life. Scientists are still studying different possibilities, But one thing is clear. The mysterious brine pools under the sea have given a new direction in the search for answers to one of humanity's biggest questions. Even so, the brine pools didn't just change the history of Earth. They also changed the way we search for life on other planets. Before, many scientists had simple ideas. If there's no sunlight, there's probably no life. But after the discovery of brine pools and other deep-sea ecosystems that rely on chemosynthesis, it was proven that organisms don't always need sunlight to survive. This means there are more places in the solar system where we can search for life. Two of the most well-known candidates are Europa, one of Jupiter's moons, and Enceladus, one of Saturn's moons. Why these two? Because according to observations from spacecraft and studies by planetary scientists, there are massive oceans of liquid water beneath their thick ice. On the surface, all you see is ice, but beneath it, it's believed that there are deep oceans that might even be larger than some of the oceans here on Earth. No sunlight reaches those oceans. In the past, many scientists thought it was impossible for life to exist in such a place. But now, the perspective has changed. If there are microorganisms that can survive in dark, salty, and almost oxygen-free environments here on Earth, it's also possible that similar organisms exist beneath the ice of Europa or Enceladus. This doesn't mean that aliens have already been found. Up to now, there is still no direct evidence proving that there is life on either of these two moons. It remains a scientific possibility that continues to be studied. That's why it's a major part of current space exploration. The search for signs of water, chemicals, and conditions that could support life. One of the most important missions for this is NASA's Europa Clipper. Its goal is to study Europa in more detail to determine how likely it is that it has an environment that could be inhabited by simple organisms. It will not directly search for alien cities or large creatures. Instead, it will look for the ingredients and conditions needed for life to form or survive. Whatever the results of the upcoming missions, one thing is clear: the brine pools have taught scientists a very important lesson. Life is more resilient than we previously thought. It can survive in places with almost no oxygen. It can survive in extreme salinity. It can survive under immense pressure. And it can survive even without a single ray of sunlight. Because of this, our understanding of what the word habitable means, or a place where life can exist, has expanded. Perhaps there are still many environments on our planet that we do not fully understand, and it might be the same in other parts of the solar system. With every new expedition beneath the ocean, we also discover new kinds of organisms and new types of ecosystems. Long live the idea that much about our planet remains unknown. And if Earth itself continues to hide such amazing secrets, even more so elsewhere, this makes us realize how much more might be waiting to be discovered in other worlds. Perhaps the next big discovery about the origin of life will not come from outer space. It may begin in a quiet, dark, and very deep lake right beneath our own ocean.